So I'm going to hand over to our speakers. So I'm going to invite Izar and Matt to join me up on stage. It's the video button. There you go, Izar, you found it.
Oh my goodness. This is going to take some.
Excellent, brilliant. Yeah, so excellent. So so I will hand over to both of you. The presentation problem is my problem. It's not a platform problem. It's my problem because I just couldn't see the screen. So you should be able to present much easier than I can because you're much better rehearsed than I am. So I'm going to hand over to you guys. And afterwards, if anyone's got any questions, please use the chat window. I will keep an eye on the chat window, please.
Okay, thank you very much. Just make a sign that you guys can hear us. Good, thank you. I saw, yeah. Okay, cool. It's going to take some time for us to figure out the situational awareness here. There's a lot happening in a lot of places, and it's been, to me at least, a long time since I last had to deal with so many events in the same place. But we'll trudge on. So yeah, so we're going to talk to you today about threat modeling, a manifesto, and hopefully we'll have time for some code even. A bit about us. Myself, I'm a principal security architect at Squarespace. I've been doing the security thing since the 90s on every single layer, briefly on the physical, but apart from that, everything up from there. And nowadays, I am poking at the secure software development lifecycle from different places and seeing how I can improve things and make them better in my immediate neighborhood and hopefully expand that to others.
And I'm Matt Coles, and hopefully you can hear me also. So
yes.
I'm, well, I know you can. And so I am a product security engineer, architect, working with primarily embedded devices and embedded systems, as well as large-scale infrastructure and ecosystems for such things. So Izar and I, as you mentioned, we've been collaborating well since 2010. Co-authored a book, and I noticed, Izar, you actually should have updated this. We need to update the slides because I added something. We had a chance to co-present at DEF CON 29 this year, remote.
Oh yeah,
we're discussing it. I did update the slide, but I think you didn't refresh. That's okay.
Wait, do I have to refresh because of the other things that you did?
Yes, please. Probably should.
Right away. Just a second. Keep talking.
So yeah, so as and you know, we want to thank Glenn and Michael for inviting us. We are well, I am dipping my toes in the DevOps or DevSecOps environments. I know Izar's got a little bit more experience than I do here. We're not going to talk about DevOps specifically today. We're going to talk about security and threat modeling. And we'll talk a little bit about how you would integrate threat modeling into a DevOps or DevSecOps environment. We will most definitely entertain questions.
Yeah, and actually, when I spoke about the situational awareness, it's just that there's just apparently so many ways that you guys can reach out to us during the presentation. But usually we enjoy doing these things like interactive. Don't feel like you have to wait until the end and keep mulling about what you want to ask and perhaps miss something that we have in the middle. If you have a question, put it somewhere here. We're going to find it one way or another. All right, so what do we have for you today? We are going to talk a bit about threat modeling in general. Just build a common base that we can use to dialogue about this thing called threat modeling. And for that, we are in large part going to use the foundation of the Threat Modeling Manifesto. We're going to share with you both a bit of the history of why it was done, what it is, what it carries, and what's the added value. Then we are going to have some discussions about techniques, relationships, and in the end, we are going to close with an example of a methodology of threat modeling that is, in our opinion, well adapted to the DevSecOps challenges. And then at the end, we're going to have a presentation of a tool that may be helpful, may be fun, may be interesting for you guys to be acquainted with. So the Threat Modeling Manifesto. We were a 15-person group that got together one bright morning about July or June of 2020 and decided that we wanted to put a framework together so that people could talk about threat modeling in a consistent way, and people could understand what it is they would be taking out of the process of the investment of doing threat modeling, and when doing threat modeling, what should be the principles and the values that would guide that effort. If anybody's interested, we had an amazing time with these folks. These people are like extremely experienced, extremely smart, great communicators, some of them. We were researchers, academics, practitioners, and the Security Journey podcast captured the behind the scenes, some of the discussions that we had when we got to what got published in the end. And we personally think that it's a really good resource, and if we may say so, an example of great work as a team. So if anybody's interested, the links are there in the bottom.
So when we talk about threat modeling, right, first off, one of the big things, one of the big challenges that we had in the, and I'm sorry, my camera's up here, the bubbles are over down there. So if I'm looking off screen, it's not because I'm trying to avoid eye contact. It's just I don't know where to put eye contact. So, sorry. So when we first formed the Threat Modeling Manifesto, one of the big things we needed to figure out, of course, was what is threat modeling, right? So we had to set a base, right? So through some good conversation, and if you listen to the podcast, both episode 1 and episode 2, you'll hear sort of the thought process that went through here. We came up with this definition, right? So basically, threat modeling is analyzing representations of a system to highlight concerns about security and privacy characteristics. So in this particular case, right, we're talking about having a system that we can create a representation of, and then look through that representation to identify things of value for us, right? And we'll talk a little bit about what that means in just a moment. Izar, next slide. So one of the other things that we need to do when it comes to threat modeling is we have to choose sort of the approach, or how are we going to tackle this, right? And so there's really a core process for how to do threat modeling, and that really can be summarized in this 4-question framework that Adam Shostak, who's one of the members of the Threat Modeling Manifesto working group, and Glenn was talking about his book, and we referenced it in ours. You know, he's a good colleague and somebody to work with, and very knowledgeable on the topic, and he came up with this 4-question framework, which we adopted as part of the manifesto for how to do threat modeling at the most basic level. We asked 4 questions. Well, really, we asked 3 questions, and later we asked the 4th. So we asked first, what are we working on? What can go wrong? What are we going to do about it? And then later we'll figure out, okay, did we do a good enough job, right? So what are we working on? What is the system? How do we represent it? What can go wrong? We then analyze that representation. Again, going back to the definition, we analyze it, looking for issues. And then we figure out from those issues how we're going to address them, right? So what are we going to do about those things? And then we can then ask that last question of, okay, now that we've put some mitigations in place, do we actually change our posture enough that we've done a sufficient job to reduce the areas of concern, right? So that's the general process for threat modeling. And I'd say 99% of all of the threat modeling methodologies that exist today that are well-defined follow this process to some extent. Right? There's always a process of, always part of the process of looking at what do we have, where are their problems going to be, and then figuring out, okay, how do we mitigate those things? Maybe that's more of a how do we fit modeling in threat modeling into the development process, but it still occurs. because nobody does a threat model and then just leaves everything dangling. Right. So is our next slide. So let's break this down a little bit further, right? So how do we model a system, and what are we looking for when we model a system? And then really when we talk about threat modeling, right, it's really two pieces, right? It's a representation, and it's threat, it's representation of the system, creating that model, and then analyzing it, looking for threats, aka threat elicitation, right? And system representation, or that model, is really the combination of elements, interactions between those elements, and the attributes on both the elements and the interactions. In other words, we have things in a system, and we'll have some diagrams later which will highlight this point. There are some things within a system, and they talk to each other, right? So, for instance, we have our desktop computers, or our MacBook Pros here, and we have a web browser, and that web browser is talking to a server and transmitting video and audio. So we have elements in the system. We have interactions, and then we have attributes on those things, on those elements and interactions, that we will then use to do threat elicitation. So we have elements and interactions and attributes, as I mentioned. We run that through some sort of filter. Now that filter, by and large, today is mostly human-based, where we use different resources to identify the set of things that we want to pull out of the model. Weaknesses, threats, vulnerabilities, for instance. And actually, let me pause here for just a moment with a show of hands. How many people are familiar with security as a topic, in terms of familiar with the terminology I'm using? And we'll go into some of the details anyway, just in case if there's a refresher needed. Looks like everyone's pretty familiar.
I counted 20 hands and 1 heart. 21.
I'm not sure what the heart represents, but okay.
But they love this topic.
I love this topic. Okay, then great. So we won't spend a lot of time. Hold on, I wasn't done with that last slide.
Oh, sorry.
So we won't spend a lot of time on the next slide, but we'll do a refresher. But so basically, just to continue this out, right? We run this through a filter, and we do that today by hand, right? We really do it by person. We will show later a method for doing it in an automated fashion, and especially that will be important for this group, because obviously this is a DevOps or DevSecOps group, and so having something that can do this on an automated fashion, sort of at build time or at deployment time, will be very important, and we'll demonstrate that in a little bit. Once you have identified your weaknesses, your threats, your vulnerabilities, that then gets fed through another filter later, which leads to risk, right? So ultimately, threat modeling is an input into a risk management process. We're not going to talk about risk per se here, only that it's an output from this process. The blue items here on the bottom are sort of some of the resources that we use today, that the industry uses today, to do both the initial filtering to get from a model to threats, and from threats to risk. Is there next slide? Okay, so again, we'll breeze through this. We have when we have a system, we have data and functionality. We want to preserve that data and functionality. So how do I cue you, Izar?
Yeah, I was answering you.
I can't build up the slides, I don't think. So why don't you just build it out completely, and we'll because it's
oh, okay,
right there.
Okay, too much.
All right. So, usually we're pretty more better polished about this, but this feels like a nice social setting, and we can be comfortable with.
We feel safe.
Yes, we feel safe. That's what it is. All right, so we have a system. That system obviously will have two major components, right? They'll have data and functionality. Those data and functionality are things that we want to protect, right? That's the value that we get out of a system. And so we want to protect that for security and privacy. And specifically, we want to maintain certain properties, right? We want to maintain confidentiality, integrity, and availability. right? So we want to make sure our data doesn't get seen by somebody else. We don't want it to be tampered with, and we want it to be available when we need it to be available, and not any other way, right? We don't want to give it to somebody else, obviously, but we don't want to lose access to it either. So how do we do that? Well, we apply a set of controls, patterns, and capabilities, right? So we do authentication, authorization, auditing, defense in depth, using defense in depth techniques to put layers of defenses in place. Or we use encryption to make sure that our data is confidential, for instance. And so these are the various things that we look for, and we look for them for their properties to be maintained whenever we look through that system, those elements, those interactions and attributes. We're looking for that information to help us determine through that filter, do we have any threats that would result from any of the lack of any of these things, right? So do we have places where confidentiality can be impacted? Do we have places where somebody isn't using least privilege on a service? These are the things that we're looking for that help drive that threat discussion. So far, any questions? Is everyone okay with this? I don't think folks in chat. Okay, I'll assume that the clap means go. So I'm sorry, it's a new platform for us. All right, so looking now back to the manifesto. How's the manifesto formed, right? So we have, we base this on, we base this on the Agile manifesto. So there's a set of values, a set of principles, and within principles, there's a set of affirming patterns and anti-patterns. So values are structured in a this over that approach. Now, it's not to say that this or that are, yeah, it's not to say that that isn't important. It's just that this gets more value than that, right? So, for example, the first one here is a culture of finding and fixing design issues over checkbox compliance. We want to do threat modeling to get value out of the threat modeling process, right? We want to be able to find and fix issues and not just get that checkbox. If we're just getting the checkbox, well, there's other things we could be doing, right, or should be doing. The value out of threat modeling is when we can find problems that need to be addressed. Another value is people and collaboration over processes, methodologies, and tools. Now, this will break down a little bit as we talk through this presentation, but really the value of threat modeling is the interaction that people have when they get together as a group and talk about a system. And in talking about the system, they make, first off, they can make certain decisions about that system, right? Are there any concerns or any issues we need to worry about, anything we need to fix? But also they can exchange ideas in a way that if you just run it through the tool, you're not going to get the same value, right? One of the best things that happens for me personally when I'm running a threat modeling exercise is you have a bunch of people in a room, you have the architect, you have a developer, and they're talking about the system. And somebody, I'll pick on the architect for a moment, says, well, we designed it in a certain way. And you get the developer say, well, we didn't implement it that way. It works differently now. Oh, really? And now you have a conversation. And so that's the value out of threat modeling by and large. Now, yes, it is a detective capability for finding security concerns or privacy concerns, but it's the value you get out of the conversation that's important, which is why it's really hard and really difficult for us who we are collaborators and maintainers of an open source project, which is a tool that does this automatically for people. So it's hard that we do that, but really the value out of threat modeling is that interaction that you get from talking about a system. And so it's an interesting balance. Another value is the journey of understanding rather than doing it as a snapshot. We'll see this later as an anti-pattern, but basically threat modeling, when you do this, it's not meant to be done once. Again, it's not a checkbox. You don't do it just to get the checkbox, right? You do it to understand the system, and you gain knowledge about the system. And as the system evolves, continuing to do the exercise, this is your journey, right? That's the journey of understanding. as opposed to just taking a snapshot. Yes, you can do that, but you lose some value, right? It may be useful for a pre-deployment step, but it is not necessarily the full value out of the activity. Another value is doing threat modeling instead of talking about it. We do a lot of talking because we try to educate people, but we hopefully you take this knowledge and go off and do threat modeling because that's where you get value from it. And then lastly is continuous refinement over a single delivery. Again, consistent with the snapshot, the compliance rate. Don't do it once, do it many times, because that's how you get better understanding and better value. When we look at principles, there are 4 key principles, right? And really, we're just going to focus on the highlighted words, right? We want to improve the security. We want to align with the organization. So threat modeling has to align with your organization in order to get the most value out of it. The value that you get is really when you have meaningful results, right? So when you do threat modeling and you get something that you can interpret and that you can take back and that you can bring into your development pipeline and make changes, then you've reached meaningful results and therefore you've gotten value out of the process. And lastly, dialogue. Again, there are ways to automate, but really the value out of threat modeling is the conversation that you get, that better understanding. Sometimes you get better documentation, but often you at least get a conversation. You get people on the same page talking. So when we look at patterns, now these are positive affirming patterns, right? What makes threat modeling get meaningful results? What makes threat modeling provide value is a systemic approach, right? So using knowledge in a structured way. There are some structured ways of doing threat modeling. There are more importantly, there are defined ways. We already talked about the 4-question framework, which is sort of that basics. We're going to talk about a couple other methods today to inform you, and that as you apply your system knowledge and your security knowledge, your privacy knowledge, using the framework as sort of a guide for doing that, that's a positive thing, right? We also have informed creativity, right? So often people are concerned that threat modeling is hard, it's esoteric, it's a thought exercise, and that requires specialized skill. Well, really it doesn't. And so there's a little bit of art, there's a little bit of science here. You have to have some knowledge, but really you have to have knowledge about your system more so than about those other topics, right? But you use that experience, use that knowledge, and you drive it through the process, and that's again how you get. It's all about getting value out of the system because you get meaningful results. How you enable threat modeling is key here with having a cross-functional collaboration, right? So people bring in different viewpoints, and that's really critical, right? You have architects who design the system, you have developers who are implementing the system, you have QA engineers potentially who are testing the system, you have stakeholders who represent customers, you may have tech support who have to deal with all the problems when when things go bad, or your incident responders if this is some of that type of system, and so having a cross-functional group of people involved in the threat modeling exercise improves understanding overall and also gets better results as an outcome. Having a useful toolkit. Now, a key thing is use tools. The tools don't use us, right? So, and Izar, do you want to comment on this? Because I know this is...
No, wait, where's the hard thing? Go on.
All right, so useful toolkit, right? We want to make sure that we select tools for this process that that we can make use of, that makes us more productive, right? So for instance, drawing a tool. You can draw a tool on a whiteboard and take a picture, or you can use something like Draw.io or Visio. But really you're using it specifically so that you can create a model that is understandable and represent your system, and that's it, right? You're not using it to do other things, and certainly if you are using a tool that puts a lot of effort in using the tool, then that's less valuable, right? Just overall, that's less valuable. and that degrades the capabilities that you get out of threat modeling. And lastly, theory into practice. So while there are all these great, there's 30 plus, there's at least 30. It's hard to keep track these days of the ways that you can do threat modeling. Really, threat modeling can be modified and should be modified specific to your local needs, right? So, if you're working in a particular methodology and there's a particular type of thing that it's looking for, we're going to talk about Stride in a little bit. Stride just, works in a certain way. It has a certain set of things you're looking for. Well, guess what? If one of those things doesn't apply to you, take the letter out and put a different letter in, right? You can modify the technique without modifying you can modify the technique and get better results without necessarily completely erasing and starting from scratch, right? And that's the key thing. So those are the affirming patterns, right? These are all the things that give us value and get us meaningful results. When it comes to anti-patterns, once you just build it out, we'll go through it. There we go. So anti-patterns. First off, hero threat modeler. Anybody can threat model. So the myth is that that only security can do threat modeling. There's one person in an organization who can do it. You have to have an expert. You have to hire a consultant. No, hogwash. Anybody can do this, right? With a little bit of experience, a little bit of training, a little bit of guidance. There's lots of free and non-free resources out there that can help people to understand how to do threat modeling. Anybody can do it. In fact, from our perspective, developers are the key folks who should be doing it, right? We want to do this at the local level. If you have to hire a security consultant, that's fine if you want to do that, but you don't have to. And I'm sure there's lots of security consultants out there who are now hating us, but that's okay. Admiration for the problem, right? We don't want to get stuck in analysis paralysis. We want to get to solutions. So when we model a system, we want to find the problems, and we want to figure out what we can do about it, right? That's why the 4 questions have 1, 2, 3, find the problem, find the problems, find the solutions. If we get stuck analyzing and analyzing and analyzing and analyzing, we never get anywhere, nor do we actually get out of that and find solutions. So we want to avoid that. Likewise, we want to avoid over-focusing on certain things. Everyone loves to talk about, oh, nation state XYZ is coming after my system. My data is going to get stolen by, some criminal gang. That's they worry about adversaries. They worry about assets. Really worry about the system, its behaviors, your team and your organization and how it gets built, and less so on who the attackers are, because the attackers will change. People come and go, organizations come and go. Really, your system and how it works and how it operates is better to focus on. And then lastly, perfect representation. So there is no single ideal view. The interesting thing about models is they're all wrong. Right? Models, they cannot be perfect, because if they were perfect, they would be the system, right? And so don't try to make it perfect, because you can't. Well, you can by building a system that is perfect. And you're always going to have different ways of expressing ideas and expressing concepts. The only place where this potentially breaks down is if you're talking about hardware, where hardware potentially has a perfect representation in a hardware model.
Yeah.
If you're a hardware engineer using VHDL or something to that effect, right? But otherwise, you're not gonna be able to represent the system consistently across the board the same way every time. Even not hardware, Mike? Yes, perhaps. That's probably true. I don't know if anyone else can see the comments when they come up, but I'm sorry if I... Can you see them?
No.
You can't see them. Okay. So I don't know if Mike commented, no, not hardware. Was that no, not hardware? Or no, not even in hardware?
No!
All right. So...
But actually, Matt, it's something that's interesting that I've been hearing lately. And I think that at some point we should go look at it. People get a bit curious when they hear that hardware can be threat modeled as well. There's an opportunity there.
That's probably true. And Mike just clarified his comment that um, that even a hardware model like in VHDL or something isn't necessarily a perfect representation. So
True.
I stand corrected.
True.
And as you can see, yes, there's no good way to create a perfect representation. And again, if you build a perfect representation, you're building the thing that you're representing. So speaking of no perfect representation, this and the next couple slides, we're going to demonstrate, you know, just exactly what we mean by no perfect representation. So here's a system, has no value whatsoever other than for demonstration purposes, where we describe a system that has a couple of things in it that talk to each other, and there's some properties on that thing. So we have what are we working on, and what can go wrong. And so this is an example. You know, if you want to put some comments in, you know, normally we would take the opportunity to do a little exercise and sort of a quiz of the audience. If you want to take a look at that and put it into chat, or I mean, you can post comments to us directly, but only we can see them apparently. So if you put it in the chat, probably better. If you see anything of interest or of concern.
John is saying injection, injection, run away, run away, eject, eject, inject, inject.
Inject, no. Anyone else? Is there anything else that people see out of this system?
Anything glaringly obvious? That the store is not encrypted. Somebody found the chat. Michael is saying that people could go on stage and join Izar and Matt.
Oh, wow. That's an interesting feature.
Mike is saying that Rowhammer and similar examples where hardware doesn't match VHDL. True, very true.
Mm-hmm. And Java, yes. Ugh.
Java. Someone used XML. You don't use XML. XML uses you.
We're old school. Speaking of useful toolkit, let's talk about that one as an example. Yeah. So as you can see, you basically did a threat model, right? We provided the diagram. You did some analysis based on your experiences and based on your understanding of security to identify a couple of problems, and that's great. Now let's demonstrate no perfect representation. Here's a second version of the exact same model, drawn differently. So the previous model used DFD, data flow diagram, which is the traditional modeling approach for threat models. You use circles and double circles and curved lines and dotted lines, and yeah. DFD3 simplifies that stencil, right? It uses basic flowchart shapes, rounded rectangles, straight lines, bidirectional arrows instead of unidirectional curved, and a little database for a data store, right? So this is a much cleaner model, but it's the exact same model as what we had before. Two different representations. Now on the next slide, here's a third representation of the same model. This encodes a different set of information. This uses a sequence diagram, which now allows us to not only include the fact that data goes from point A to point B, or from component A to component B, but in what order does it happen? Now we can use this for additional information for doing threat analysis, right? We may have certain threats that only appear because of temporal information as opposed to just simply attributes about the system. So hopefully that underscores the point around no perfect representation. Last thing I'm going to talk about before we jump into the next section. Once you hit next on this, Izar. One more. Okay. So speaking of no perfect representation, there's also no perfect representation when it comes to processes. And so these are 4 out of, again, the 30 or so threat modeling approaches that exist today that are documented and defined. One of these doesn't even use models. It doesn't use a data flow diagram or a sequence diagram. It uses basically a spreadsheet to identify and itemize the elements, the interactions, and the attributes. And it is through these combination of things. Okay.
We're being invaded.
Alina, if you had a comment, we would certainly answer it if you want to ask it, or come on up on stage, I guess, however that works. Either way, but in the interim. So Tara, for example, uses spreadsheets, as I mentioned, and then you have Stride, Linden, and CTM. These are three additional processes or three different approaches to threat modeling, one being security focused. Stride is the most commonly known, maybe not the most well used, probably the most well used also, but at least the most well known approach for threat modeling. Linden is a version that is privacy focused. It uses the same structure, but it uses a different set of the acronym is different. And then lastly, you have CTM, which itself is an acronym only because it's hard to say continuous threat modeling. But it's the approach that is really geared towards agile development and potentially hooks well into a DevSecOps approach, which is why we're going to talk about it in just a moment. So why don't we go, actually, next slide. We'll pause here. Hit the button one more time there, Izar. There we go. Pause. Any questions before we move on?
Alina can't hear anything.
Can anyone else hear us? Hopefully anyone else can hear us. Okay.
Yes.
At least a few people
Okay.
can hear us.
Okay.
All right.
Okay. Everybody
So,
can
Alina,
hear.
if you can't hear, well, actually, if Alina can't hear anything, I don't know, Glenn or Michael, if you can maybe help.
Turn it off and on again.
All right. So, Izar, I will pass this on to you.
Indeed. Okay, so you keep an eye on the chat. There are some good questions coming up in there. So for the show and tell part of the day, oh, wait. We have a question in there.
Yes, we do.
How do you stop yourself from scope creep? I tried modeling a CI/CD pipeline, and it quickly got out of hand.
So
interesting.
Let me start with, I'll start with an answer, and then Izar, I'm sure
Sure.
we'll have some thoughts. So remember when we talked about some of the patterns and anti-patterns? It's up to you how deep you go. It is important to note, and I'll just call it out there, that, and I'm a big proponent of this, that basically with threat modeling, you start with basically zero knowledge and you build up your knowledge base as you go. So you start modeling a system and you add things to it, and as you're adding things to it, you learn more and more about the system. So when you talk about scope creep, well, so first off, there's an artificial boundary that you're not setting, and you can, right? Feel comfortable setting limits, right? So as you're modeling your CI/CD pipeline, you're going to start, putting in a couple build servers, and maybe you have some scanners, and you're going to have, your source repository and other things, and maybe that's sufficient to get what you need, right? So really, you need to set your goal, your objectives. What are you trying to meet? And go up to those objectives. If you're bringing in other systems, okay, maybe table that. Or if if you're calling out scope creep as the system gets very large, well, okay, that's fine. Maybe your system is very large, very complex. You'll also try looking for some ways, some tricks in both the modeling process as well as the analysis process to simplify things. Sort of like in math, you can take certain variables and you combine them together. They sort of look the same so that you can replace them with a placeholder. Well, maybe you can take that with some of your systems and just bring them together, right? Rather than modeling, if you have a cluster that scales out, right, to scale out resources, you really model that once, and you model the fact that it can scale out to multiple resources. You don't need to model the individual scale out items, right? So you can simplify your model, and that way you can reduce your complexity. But feel free, be comfortable setting those boundaries so that you can reduce complexity or maintain complexity, abound on complexity. Izar, do you want to add anything to that?
And it's also a lot about, yes, it's exactly like eating an elephant. And it's also about managing your appetite for risk. I mean, it's great that you are able to elicit threats to a point that things get too big. But at some point, you have to say, these are the up to here I can fix, and up to here I have to accept. And as long as you're informed to what is what, that's a good way to reduce complexity or to reduce the size of things as they appear. Another thing, and I think that Matthew already alluded to that, is that when we talk about DFDs or other diagrams, we perhaps are not alluding to the fact that they come at different scales. So each one of those boxes that you saw in the DFD by itself could become another DFD, which only looks at that part of the system by itself. So you would have a level 0 DFD with the 30,000 feet view of the thing. And then you would get down to the components and decompose each one of them, DFD that, or do other kinds of diagram on that, or do a verbal description on that. But in this way, if you get the top thing too complex, you would be able to subdivide and attack the complexity in a smaller, more focused way.
And Philip asked a good question around how to assess a third-party service and how to focus in on the priority controls. Izar, do you want to tackle that first, or?
Yeah, so that's something that I've been doing a lot in in this job and the one before. The one before was in the financial sector, and they put a lot of focus on understanding what risk they are bringing into the enterprise. And the fact that threat modeling without information is basically nothing. One of the things that we say is garbage in, garbage out. If you don't have good information coming into the threat model, you're going to have bad information going out. So when you're doing a third-party component or a service and you're trying to threat model that, sometimes it all depends on what kind of information you have about that thing. If it's a totally black box thing and you have to do a lot of assumptions, at the end of the day, your risks will probably just be exactly that, assumed. But if you are able to ask the right questions so that you can build that risk even from a black box approach, and we know that that's possible because it's what attackers do all the time, even if they don't know, mentally they have a threat model that they are following in order to attack their targets. So I find that the secret here is really having a good intake questionnaire, meeting with their security people. And sometimes you could be even able to ask them, do you have a threat model, and can you share it with me? More and more we are seeing companies that are ready to do that. Perhaps they will take things that are, things that they need to, but they appear to be very, many of the ones that I've been dealing with lately, they appear to be very open to the idea of sharing their own threat models with you. Okay, let's go to the next thing. So for the show and tell part of the day, we have two things. We have a bit more about continuous threat modeling, CTM, and then we're going to talk about PyTHM. CTM, as Matt described, is a methodology that we think that is very well adapted to the world that people from DevSecOps live in. Why? Because first of all, it approaches the whole thing with developers in place of architects. So you remember when Matt described the situation of the architect saying, hey, this is how the design works, and the developer in the back of the room coming in and saying, hey, yeah, but we had to change the implementation because the constraints were different, right? So that's what we like to call an eureka moment. You didn't know that, and all of a sudden, eureka, now I know how my system works. But the fact is that when the developer got that story to implement and looked at it and said, this is not going to work as designed, I'll have to do it in another way, they are actually having an opportunity to introduce risk. They are having another opportunity to mitigate that risk. So the place where CTM attacks is exactly that point in time, where decisions are made by someone who is not perhaps responsible, but a participant for the original design. Also, design and implementation, they happen together, as I just described, and they are cyclical. Things happen in a snowball manner rather than a waterfall thing. We recognize that training is not enough. Unfortunately, rare is the occasion where the training program of a company gives developers what exactly they need to do, and it's actually in a form that they can consume. So we have to provide them with, I don't want to use the word tools, but with neither resources, but with something that takes them by the hand in a way that the training would do if it was good. So something to focus them on the problem. Also, we need to shorten the flaw to fix kill chain. Sometimes when we identify a flaw to the point that we mitigate it, too much time passes. And that's when you get breaches and when you get all kinds of funky things happening. We need to reduce that time. And at the end of the day, something that we learned by experience, threat models are great for documentation. If you take into account the big developer maxim of it was hard to write, it should be hard to understand, a threat model is a great place to look at the design, look at the assumptions that were made, look at things how actually work, and keep it for posterity so that other people joining the team or people that have to maintain that system later on will actually have a clue on how that thing works. Now, PyTHM, actually, you know what? Let's talk about PyTHM when we get to PyTHM. So, continuous threat modeling in a pinch. And I apologize because my diagrams are nothing like Matt's diagrams. Okay, he apparently has a talent for bringing big ideas into good representations, and I suck at it. So basically what you get is this. This is a flow chart, which is too small for you to read, so don't even try. But what I want to bring to you is that basically what we have in here is two loops. The first loop we call the baseline loop. And the second one is the continuous part of it. Now, the baseline happens when people are triggered by the famous mating call of the threat modeler. Oh my God, I need a threat model. When that happens, and it could be because somebody's checking boxes, because somebody just heard about the technique and thought that it would be a good idea to try, or because somebody actually has a clue and says, hey, we are doing a new thing, we should threat model. When that happens, everybody gets together in a huddle, model the system, elicit threats, and document them, which is basically what we've been talking about for the past, I don't know, 40 minutes. So far, so good, right? Right. But then an interesting thing happens. We documented the baseline, we documented the threat model, let's call it like that, and then development started. Let's say that we were fortunate enough that this thing happened at the design time and the system doesn't exist yet. So development starts. As development starts, we fall into the trap of the eureka moment. The developers start figuring things out and noticing that as designed, that thing wouldn't be as good as needed. So they go and they make changes to the design as they go. And the challenge here is how do we incorporate that into the original threat model? So what was happening in the normal waterfall situation is that you would have a big effort in the beginning when the design happens to threat model that whole system. Then you would have silence on the wire until the end. And 2 days before deployment, you would have another big effort to take that initial baseline threat model, take all the changes, figure out all the changes that happened during development, and create a new version that actually does model the system. Huge effort. Everybody would get extremely frustrated. And usually that's how security team would get their bad name, because this would happen just in front of deployment or release. And people would say, why do you come to us with this now? Why is this a gate? We don't have time. We can't do anything with what you find. That's the one that killed me the most. What's the point of you finding things if we can't fix them before release? But actually, that's what happens. So in order to solve that problem, we get the continuous loop. Now, the continuous loop is interesting. Why? Because we are here on, can you see? Yeah, we are here on developing, right? So now the developer picks up the story, looks at the story and says, hey, does that thing have some security value? What security value? Interesting, you should ask. Developers normally cannot answer that question, but that's where we are going to provide them those resources so that they can be educated on it in real time. And we're going to get back to it later. Basically, what we have here is if this, then that checklist. And that checklist says things in developer language. Something like, have you added a new process? Things that a developer knows how to look at it and say, you know what? Yeah, I just added a new process. No security thing at all. And that is the if this. Now, on the other side of the equation, the then that, that's when we start adding security language and saying, oh, you added a new process. Nice. Have you looked at using a list privilege on it? And the developer goes, list what? And then we give them a blurb. What's list privilege? Have you made sure that the rights that you gave to that process are only what it needs, not anything more? Oh, okay, cool. I can go back to my process and check that. I know what the process is. I know what rights are. I definitely know which ones it needs. And if there's anything there that it doesn't need, then I'm just going to negate that thing. Great, we just found a possible flaw, mitigated it, go on with life. How? By adding that to the development and just moving to the next story. Now, by mitigating, creating a threat model ticket so that the fact that you thought about that and the fact that you mitigated it goes into the threat model, and that's the part that keeps the threat model up to date with development. And then, yes, you move back to developing and you pick another story. Now, if that thing has no security value, then, like, for example, fixing documentation, which many times may have security value, but most times doesn't, then they just do what they need to do and move to the next story. Now, if the system is not in development, is in maintenance mode, great. Just rest until you have to add some feature, and you're done with it. Any questions in here? Anything that I tried to explain and didn't do a good job of? Okay. So let's talk PyTHM. This workflow that the developer, yes, it is.
Well, actually, can we just interpret that question a bit more? It is not a must.
Oh, yeah, true.
Right.
Oh, most definitely. But that's an interesting question, because we give the checklist to the developers at the beginning of the thing. At that time, they are clueless about security, let's say. So as they write their stories, they are going to go to the checklist and check it, and then check it again, and then check it again. By human nature, what they're going to do is they're going to develop muscle memory. At some point, they'll say, I don't need the list anymore. What we see when that happens is that the thing goes from postfix to prefix. So instead of writing their stuff and then checking the list to see what is it that they did, because they have the muscle memory, now they actually act on the list, before they actually write it. So while, yes, there is a difference in delivery speed, it tends to go down with time. But most important is, and that's a mistake that I've seen a lot of teams do, delivery speed is not the holy grail. A system that works the way it's supposed to, does not break, and is not breachable, that is the holy grail. So if you don't invest that time right there, what's going to happen? You're going to write bad code. Bad code is going to get breached. Breaches are going to cost money. They're going to hit your brand, and they're going to put your developers in emergency mode, right? So you are going to have to deal with way more time and costs to fix that breach than that little kick in the delivery speed that the developer had to pay when he was or she was writing the story. Okay.
And actually, just to reiterate that point, right? So Aidan, you also called out, maybe we need a champion. Well, if you want to use a champion to sort of shepherd through the process, right? Sort of the way that your Scrum Master might shepherd the development team through the Scrum process, or a project owner may shepherd, features through the process. That's fine to get started, but the goal here is, again, to develop that muscle memory, right? So in the beginning, you're going to be referring to lists. You're going to maybe need some prompts. You're going to need somebody to be, maybe you need an expert on hand to guide you through the process or to understand what needs to be done. But as you go through the process, your velocity will improve, and your sort of the amount of help that you need will decrease, right? Because as developers, or as engineers on the team, right? It'll become, just part of the process, right? Today, nobody helps you, nobody coaches. Well, maybe as a new engineer, somebody may coach somebody on how to code, or how to use a development tool, or how to do a build. But those things eventually become, just like, muscle memory, right? That just happens. CTM helps the same thing with security or privacy, right? That's the goal, is to try and help as a means of training on the job some complex things that today tend to be more gates than guides.
And since in the beginning I said that we feel safe, I can tell you, don't get me started with security champions. Okay, my motto of security champions is Tina Turner, we don't need another hero. But once somebody asked me in a talk, oh, so this thing makes of every developer a security champion. No, it makes every developer security competent, which is something that they have to be if we want actual problems to go down. Having this guy floating on top of them saying, I am the security champion, let me bless your code, does not lead to the results that we usually think it does. Anyways, making of PyTHM. So, actually, Matt, would you like to go over the making of PyTHM?
Sure, why not? All right, so PyTHM. So we didn't actually do well. We had that blurb before. So what is PyTHM? PyTHM is a open source project. It is written in Python 3. It is available on GitHub, and its goal is, or its job, its function really is to be able to describe a system, that system model, the elements, its interactions and attributes, and identify or analyze that model for security threats. So how do we do that, or how do we build a system that that we can use, and just in general, how do we do that, right? So first off, we need to have a schema, right? We need to have ability to describe a system, so describe elements, and to describe attributes on those elements. In this example here on the left-hand side of the screen, right? For things that we can things that we can put into a model that we will then use to analyze, right? So here we have a schema for an element. That element has a type, has a name, and has a purpose. It may expose a certain number of ports. It may contain a certain type, some certain components, and it may connect to some things. It may listen for connections from other things, and all of that can be described and build the model from that. Now, keep in mind, we're building that model in code, right? Specifically, there are objects that get created. We write, the object dot property name, and the, basically getters and setters, and construct a model which we can describe an element or a set of elements. We can then take those elements and encode a set of rules that can look at that information to identify a weakness or a threat or a vulnerability. And then we put that all together through an engine of some sort where we can load a model, we can parse a model, we can sequence that model, if we want to put it into an order, if we want to do sequence diagrams, for instance. We can analyze that model, and then we can, more importantly, spit back out the model, right? So when we talked about useful toolkit, right? We talked about, let the tool, use the tool, don't have the tool use you. In this particular case, we're talking about, rather than build the model up front, we describe the system. We basically create the model up front, but we don't create it visually. We create it in terms of as a program, and then it can spit out the model later. We can render it to a PDF or to an PNG file or whatever, as a diagram, both as a DFT or as a sequence diagram, and other types of models like that, representations like that. And then a reporter and a calculator, basically, if we want to do risk scoring and basically generate a nice report. PyTHM doesn't do all of these things, but all of these things would be necessary to create a system, or some or all of these things would be part of a system that would automate the threat modeling process. And we've built some of these in. And we're going to talk through that in the next slide, I think. Izar, go ahead.
Yeah, just before we go there, some of the side effects that we found with PyTHM. So it started as Matt just described, but then came the pandemic and things became distributed, more distributed than they were before. And people found out that in making diagrams, sometimes the maxim that engineers are visual people doesn't really work. And even though we have a lot of interfaces on the web that you could use to collaboratively construct a given diagram, we found that some engineers prefer code. They prefer to describe things as code. And another thing is that even though it's PyTHM, it's a Python-based thing, that's just because we needed something to run it into, right? But as you'll see, the actual syntax is just pure object-oriented thing. Anybody coming from Perl, do you guys remember Perl? JavaScript, C++, anything will basically recognize it. It's element.attribute equals value, right? So, for example, I had a session where I had developers in both sides of the ocean, and they were writing to the script at the same time, committing it to a central repository, and every time that we run the repository, we would get the up-to-date thing that you're going to see. So what we're going to see today, and because I have fat fingers, we are not going to see a demo, we're going to see slides of the demo. We are going to see how to define the components of the model and their relationships, the data flows between them, how to generate a data flow diagram or a sequence diagram, how to annotate the components with their attributes, and how to generate a report. This is the most minimal PyTHM script you can write. It basically does absolutely nothing. But what we have in here is the call for Python 3. We import objects that we are going to use in the elements that we're going to use in the threat model. We declare a threat model object that's going to hold everything. And then after a lot of stuff, we call tm.process, which basically does the magic that PyTHM is. I really have to remember that I have highlights for those things. Okay, no more highlights, I think. No more highlights. So how do we define the basic elements, the things, the blocks, the blobs that are in our element, in our threat model? Let's start with these 4 simple ones. A user, who happens to be an actor. We give it a name, customer. A client that the customer is going to use to do its stuff, and it's a GUI. A server, which the GUI is going to talk to. And a data store that's going to save our data. Now, what this gives us is just an idea of who's in there, right? Now we need an idea of how do they talk to each other. So we define data flows. So we say, for example, that load data is a data flow between the database, the data store, and the server. And in there, we load process data. Now, the syntax has changed a little. Instead of the label load process data, actually what we accept now is a data object, which by itself has attributes. And that lets us understand more about the model. But you get the idea. It's from, to, and what data goes over the data flow. With only that in hand, you invoke PyTHM, and you get these. You can get these 2 diagrams. Now, as Matt has alluded before, there's a lot of ways to skin a cat and to represent a model, and these 2, by PyTHM represent exactly the same system. They model exactly the same thing. But as you can see right now, it doesn't give us a lot of information that we can start making security assumptions about, right? So we add one more thing. We add trust boundaries. In here, we are defining two boundaries. One that's uncontrolled by us, one that is controlled by us. One that's public, one that's protected. And then we are saying that the user is in the public boundary. The client is in the public boundary, but the server and the database are in the protected one. When we, again, run pytm, this is what we get. So now things start changing, and we already have a bit more information to start doing educated guesses about our security. Who has a higher level of trust? Who has to authenticate? Who has to authorize? Who has to talk in a certain way? But even that is not enough. So now we can, for example, say that the data that a given system, a given element in that system is able to deal with is maximum restricted. So we follow the normal military approach of public, private, restricted, secret, top secret, or confidential. So you can say that the classification of a given element is restricted, for example. And then when you start passing data from one to the other, you say that that data is top secret. And eventually, if we see top secret data reaching a restricted system, we're going to flag that as a data leak. Other things that we can see here, we can say which protocol is going on in a given element, what's the port in use, if the system has been hardened at all, if it knows how to sanitize its input and encode its output, and if it authorizes the source. In the end, what we have is a very simple template language that we use to express the things that we find with pytm. So you can use any form of text-based output. We are completely agnostic. In this case here, we are outputting Markdown, which later on we can use something like pandoc to transform into HTML, Word, whatever you want. But basically what you get in here is what you see on the, I won't even try, on the side of the screen. And that's the expression of a threat, for example. If we bring everything together, this is the output of the sample template that we provide together with pytm. So you have a diagram on the top, you have a description of the data flows, you have a data dictionary that right now is actually more complete than what we see here. And then you have a list of the potential threats. Now, a word about those threats. We are going to be the first ones to say they are a low-hanging fruit. You are not going to find anything here that you wouldn't find by just doing it by yourself. What you are going to find is you're going to find them all in one place and much faster. But the threats themselves, they come from KPAC, ATAC. From the Microsoft Threat Modeling tool, we took some, we added the ones that are based on data. And we are constantly adding more. So if somebody wants to go into the project and doesn't want to write Python code, then you are more than welcome to go into the threats and add more. This is an example of a threat identified. We have which element started in which element the issue was found. Then we have a sample severity, and it's important to say sample. We are not calculating severity here. We are suggesting an average severity for that kind of issue. Then you have an example instance, like how does this thing happen out there? And you have an example mitigation. What can you do about it? And then we provide you with references that will give you much more material if you actually need to go deeper into that. Why is it not going? Oh. Serious. Okay. So this is what we had for you today. We fall into our resources slides. First thing that we have is the manifesto, of course. Second is our book. Happy that you guys stayed for the whole thing so that you can go through the raffle. a link to PyTHM. Now, the Autodesk Continuous Threat Modeling is one instance of CTM that has been documented and put out there by Autodesk. They open sourced the thing very graciously. We have Adam Shostak's book on threat modeling designing for security, which is a classic. Brooke Schoenfield's Securing Systems. That is an amazing resource for you to look at examples of systems, their threat models, the mitigations, and a discussion in depth of those details. And if you need something a bit more, a bit shorter for threat modeling, then the last resource is a paper that we collaborated on by SafeCode called Tactical Threat Modeling.